Talk about lines and angles today, and the first type of lines we're going to talk about are parallel lines. The symbol is in parentheses. The symbol for parallel lines is just two vertical segments. Parallel lines are coplanar. Which means in the same plane, and do not intersect. All of these grout joints in the wall would be an example of parallel lines. Perpendicular lines. And that symbol is an upside down T. Intersect. At 90 degrees. We've also got this symbol. The little red half of a box. That symbol means 90 degrees. Skew lines. Are not coplanar. That means they're not in the same plane. Skew lines are not coplanar and do not intersect. And then parallel planes. Do not intersect. You guys remember what these little red arrows mean? Parallel to? If N to S has a little red arrow on it, and so does M to R, it means that they're parallel to each other. If SP has two little arrows on it, and RQ has two little arrows on it, that means that RQ is parallel to SP. So let's assume that everything in this picture that looks parallel is parallel. Okay? And let's list some parallel segments. Some parallel segments. NS is parallel to MR. SP is parallel to RQ. What's KP? K to P parallel to? L to Q, right? Is it parallel to N to S? It is, isn't it? And it's also parallel to M to R, isn't it? Okay? Those are all parallel segments. Skew segments. All right, do you see this vertical segment, NS? NS and KL are skew. Do you see how NS is in the front plane of this box? It's the front left corner of this box. And K to L is in the back and top plane of the box. They're segments that are in two different planes, and they do not intersect. Those are the definition there. That is the definition of skew segments or skew lines. So in this case, NS and KL are skew. What would another example of skew segments be? Go ahead. ML and M to L. So top right corner. Actually, there is a plane that cuts this box diagonally. So ML and SP are technically on the same plane. ML and like KP are skew segments. M to L is on the top right-hand corner of the box. KP is a vertical segment in the back left-hand corner. Those are not in the same plane, so they are skew. They don't intersect, and they're not in the same plane. Perpendicular segments. I'm gonna use the abbreviation, the symbol for perpendicular. I hate writing that word out. Perpendicular segments. In this case, we got NS. What's NS perpendicular to? Vertical on the left. SR. Very good. SR. And you see how you write it? NS is perpendicular to SR. What is MR perpendicular to? MR is perpendicular to RQ and RS, isn't it? All right? RQ. And then parallel planes. We'll go parallel planes. Remember how to describe a plane? 3 non-collinear points and maybe the little plane symbol, the pushed over box. Let's talk about the front plane of this box, NMR. Plane NMR is parallel to plane That's the front of the box, isn't it? NMR. NMR. What's it parallel to? KLQ. Very good. Plane KLQ. Front of the box, parallel to the back of the box. The right side of the box, MLQ. What's it parallel to? NKP, right? Left side of the box. The top, KLM. The top of the box is parallel to PQR. Very good. The bottom of the box. All right, top of page 147. 5 more definitions. Now we're talking about angle pairs and transversals. So a transversal. Intersects 2 coplanar lines. At 2 points. So if we got a line here and another line, those are 2 lines in the same plane. We'll call this line R and this line S. What the heck just happened? A transversal intersects 2 coplanar lines at 2 points. So if we draw a line right through here, it meets the definition. We'll call this line T. And in this case, this is your transversal. This red region would be considered the interior of the 2 lines intersected by a transversal. This blue region on the top and on the bottom, in this case top and bottom, could be left and right, that is considered the exterior of the 2 lines. The transversal that intersected the 2 lines R and S created 8 angles. And in this, where T intersects R, you have 4 angles here. Angle 1, 2, 3, and 4. And where line T intersects line S, you have 4 more angles. And this is 5, 6, 7, and 8. And all of these angles, or angle pairs, are going to have names. So let's talk about those names. Corresponding angles. Corresponding angles. Let's just use the symbol for angle and then apostrophe S. So pairs of corresponding angles. Corresponding angles hold the same position in their own set of angles. Here's what I mean. Where T intersected R, there was 4 angles, agreed? And where T intersected S, there was another 4 angles. Okay? Angle 1 holds this top left position, doesn't it? What holds the top left position in this other set of angles?
Angle 5.
Angle 5. So angles 1 and 5 are called corresponding angles. So angle 1 and angle 5. What's another pair of corresponding angles? Good, 2 and 6. Another pair. 4 and 8, right? 4 and 8. And what's the last pair?
3 and 7.
3 and 7. Everybody see that? It's real important that you understand these definitions because there's going to be rules based on these definitions. Okay? So you have to understand what corresponding angles are and where they sit. Alternate interior angles. Alternate interior. They sit in the interior of the two lines. They are on alternating sides of the transversal. So one pair of alternate interior angles would be 3 and 6. They're in the interior region and they're on alternating sides of the transversal. So what's the other pair of alternate interior?
4 and 5.
4 and 5. 4 and 5. They're in the interior and they're on alternate sides of the transversal. Alternate exterior. Same definition, except these angles sit in the exterior.
So one's like 1 and 8.
Yes, 1 and 8, exactly. So 1 and 8. And what's the other pair?
2 and 7.
2 and 7, good. All right, and the last pair, we're going to call them same side interior. And that definition it's self-defining, isn't it? Same side of the transversal on the interior or in the interior region.
So 3 and 5.
3 and 5 would be one pair,
4 and 6.
and then 4 and 6. Now, don't write this down. You can just watch. I'm going to kind of rotate this picture a little bit, and then we'll talk about it so you don't get confused. Because the two lines that are intersected by a transversal, the two lines can be more vertical. See line L and line M? And they're intersected by line N, right? Again, it still creates 8 angles. But do you see where the interior region is now?
Yeah.
This is your interior region, isn't it? In between L and M. So what's a pair of alternate interior in this case?
2 and 7.
Good. What else?
4 and 5.
4 and 5, 2 and 7. Good. Alternate exterior.
1 and 8.
Okay. 1 and 8 and
3 and 6.
good. Everybody all right with that? Same side interior. Good. 2 and 5 and 4 and 7. What corresponds to angle 8? Very good, angle 4. And what corresponds to angle 3? 7. All right, well done. Any questions? Your assignment for today is on page 148, 2 through 13. And then over on the other page, you can do 14 through 25. And be sure to check headline for homework.